This is an example of a hypothesis test for a mean when sigma is unknown. In an analysis investigating the usefulness of pennies, the cents portion of 100 randomly selected credit card charges are recorded with the following information. The sample mean was 47.6 cents and the sample standard deviation was 33.5 cents. If the amounts from 0 cents to 99 cents are all equally likely, the mean is expected to be 49.5 cents. Test the claim that the sample is from a population with a mean equal to 49.5. Use a level of significance of 0.05. Now this is a t-test. Because this is a test about a population mean where sigma is unknown, and we have a sample size that's greater than 30, so the conditions are met to be able to use the t-test. Setting up the null and the alternative, the claim is that the sample is from a population with a mean equal to 49.5, so that's mu equal to 49.5. This is the claim. Because it contains the case of equality, it is the null. The alternative will be not equal to 49.5. No sense of direction is implied in the problem. And I'd like to use the p-value method for this example. So I'm going to go ahead and get my standardized test statistic and p-value directly from the TI-84. If you wanted to find the standardized test statistic by hand, you could by using this formula, x bar minus mu over s over the square root of n. But then to find the p-value that goes along with this, you would end up needing to use technology anyway because the t-table is limited with respect to area. So to get the test statistic and p-value from the calculator, I'm going to my stat menu, over to tests. Option 2 is the t-test, and I have the summary statistics. The value from the null is 49.5. The sample mean was given to be 47.6. The sample standard deviation 33.5, and my sample size was 100. This is a two-tailed test, so I need to change the direction of the alternative and then calculate. The corresponding p-value is 0.572, and that test statistic is negative 0.567, rounded to 3 decimal places. Now, when your p-value is greater than alpha, the decision is to fail to reject the null. The p-value from the output was 0.572, and my level of significance was 0.05. 0.572 is clearly greater than 0.05, so my decision is to fail to reject the null. So the correct way to state this is that there is insufficient or not enough evidence to reject the claim that the sample is from a population with a mean equal to 49.5.